All right. I hope you can see me. I hope you can hear me. My audio is audible. And welcome to this live stream. Feel free to write a comment where you guys are from, what are you doing, and what are you expecting from this live stream or this webinar. And I'll be happy to answer your question. I'll just wait a few minutes for people to come here and join the live stream because I'm starting exactly at 12. I still have a few minutes to join. But feel free to write some comments about who you are, where are you from, where are you watching from, and what are you expecting in the stream. All right, so today in this stream, what are we going to do? We're going to solve one PLC exercise from this book. I hope you can see it. It's a PLC exercise book from Tom, and he's writing wonderful books about PLC programming, and I'm trying my best to find some time to create some digital twin examples from these exercises. So what you see on my screen is actually a digital twin, a tiny example of automatic can filling. All right. Wait a second. All right. So I have my eyes on the comments. So welcome, Mohammed. Welcome, Bashir, Noman. Welcome. All right. So what we are going to do today. So first I'm going to explain you the exercise. What is this exercise? And then I will tell you how I created this exercise in addition to a twin platform, which is SIMUMATIK. What are the various parameters, what are the variables, and how you can also emulate your own ideas if you have. And then I'm going to write a small PLC code to automate the sequence. And then finally, I will tell you if you want to work on SIMUMATIK or if you want to enroll in my free course where I have more of these examples, how can you do that? So stay tuned and I'll be answering all your questions. So hello, Part. I'm watching the comments on the other screen. All right, so let's begin. So the exercise which was in this book, this was exercise 2.13. I don't know if you have this book. If not, I put some photos here. The exercise says you have to fill water into jerry cans. So, okay, so here it was water, but I'm using some cans with some other food or stuff. But the exercise says you have a motor, and this motor is connected to a conveyor, which you can see on my photo. And when the motor is running, the can is moving towards the right side because the can is on the motor. And then you have these two sensors, B1 and B2. With the positioning of these sensors, you can stop your can. Okay, so when the sensor B1 is off and B2 is true, it's mentioned here. This means your can is properly positioned. You can see that on this diagram here. And then you start filling it using Q1, and then you have a sensor B5, which will tell you if the can is full or not. When it's full, it moves forward. So actually, it's very simple exercise, right? And you can see the result of this exercise here. Here you have, instead of jerry cans, I have these small cans, and it's coming, and you have two sensors positioned just as mentioned in the exercise, which I used to stop the can. And then there's a filling operation going on. I have a little bit more some crazy stuff because the nozzle is coming up and down, and I'm filling, instead of water, I'm filling some soup or some goulash. And then I have a sensor which senses the object when it's full, that it moves forward. All right. Welcome. I'm just watching the comments on the side. So welcome everybody. So, and once it's filled, then it keeps moving forward and the next can is coming, and it's a very simple process. All right. So how do I realize this process? So I created this process on SIMUMATIK. So I'm going to show you for SIMUMATIK. I'm going to explain you all the different elements, and then we can start with programming, okay? So my SIMUMATIK is over here. So that's my process. And just to let you know, you can sign up for free for SIMUMATIK, and you can use this application right now in CODESYS. You can program it, use it right now while watching the webinar, okay? You can sign up for free. And the only limitation for free account is you can't create system, but you can use the system which I already created, okay? So if you just click on load, once you sign up, once you come to this page, and if you just type here, filling, okay, this must be this one. I think there's a typo, filling water. This exercise will come up and this will load on your screen, all right? Now, in this exercise, I can show you how I try to make it as similar as possible as mentioned in this book. All right. So here you have this conveyor and there is this motor. So this motor is connected to the conveyor. Okay, so when the motor is on, the conveyor starts moving. It's very simple, Boolean on and off. All right, and this little guy here, this blue thingy, is which will provide me the cans. So it will drop some products. Okay, so I created the can, and this can is a very special can. I'm going to tell you shortly. So the can will come here, and then it will travel on this belt conveyor. And then you have these two sensors, basically photoelectric. So when the can passes this sensor will true, and this will get false. With this condition, I stop the can, right? And then I start filling with this nozzle. This will go up and down. And this nozzle is filled, or it's providing two types of liquid. One is goulash and one is bean curry. And this goulash and bean curry can be controlled. So you can empty that using this button. You can fill that using this green button on top. All right. And finally, this is the sensor which will tell you if the liquid is full, there's some set point. And then I read that set point. I generate a Boolean signal, and then it moves forward. All right. Now, I told you in the beginning that this can is a bit special. Why it's special? Let me bring that. So I will add a component. And I have this tin can, and I open this. So you can see that this can right now here has a top. So it has a cover on the top. All right. If I go to the asset, so here I can show you a tin can. So this is basically just the can, but there's also a lid on the top. But this lid is not part of this component. It's a separate component. So I can open this lid as well here. All right. So what we can do later in this example, we can also cover the can with a lid. Okay. In this case, I will just show or hide the lid. Okay. And not only that, you can also put a label around it. For example, there is a label for goulash. And you can see that, oh, sorry, this is a goulash. So this is basically what is going to be filling inside the can. So we try to emulate that, okay, emulate this process. And I'm also going to fill it with bean soup. So this is just a 3D data of a bean soup, right? This you can easily create on Blender. And then you have some labels. So I can also label this can later on. So right now in this exercise, you just see the filling process. But in the later live stream, if you want to join me again, I can show you how you can put the lid and how you can put the label around it. So this will come later on. So that's why I told you this can is special, because we are just trying to hide and show different elements inside. And this is the script, how this can behave. So I will not go too much into detail, but here you can see that if you have a content of goulash, then goulash will be visible, bean will be false. If bean soup is coming, bean will be visible, goulash will be false, and so on. So this is coming basically with the process of data writer, data reading and writing. And if you want to learn more about that, we have many courses about this. Okay, so this is just, I wanted to tell you how the can is being filled. So we just animate the filling process, put the can, put the label later on. Okay, and how the question is how this whole emulation part is going to be connected to CODESYS, because I'm going to program it using CODESYS. I have my CODESYS running over here. That's my CODESYS program, right? I'm going to program it here, but this CODESYS is going to be running in my soft PLC. So I don't have a real PLC. I will connect my CODESYS soft PLC with SIMUMATIK, but how it is happening? So your sensors, your conveyors are not directly connected to CODESYS. There is some guy working here, and this guy is over here. I can show you. This is the PLC. This is a SIMUMATIK generic PLC, digital twin of that. And this PLC is collecting the signals from all the sensors, and it's giving the output to all the actuators, right? To the conveyor, to this soup filling mechanism. And this PLC is actually connected to CODESYS by OPC UA. So you can see that here we have a driver type. So this PLC has several drivers it supports. I'm using OPC UA client. If you have a Siemens PLC, you can also use OPC UA. But we have S7 protocol that will connect directly to Siemens PLC. Or if you want to connect via SIMET, you can also do that. If you want to connect to Beckhoff, you can use TwinCAT driver, you can use UDP driver. So there are multiple drivers also for Allen Bradley, MQTT. But I'm using at the moment OPC UA client. And when this OPC UA client is running, I have my analog variables here, mention goulash level, bean soup level. So I can also have a feedback of my level. So let me see if there is some comments here. Part is saying, if it's possible, end of the webinar, please upload this video on your website. Just to let you know, this video is going to be in the course, and this course is free to join. I will show you in the end where is this course you can find. All right. So this PLC is connected to CODESYS, and I have some variables defined here, like input 01, which is for digital, output 01, and these are the same variables I have also defined in my CODESYS. I can show you here. So input 01, output 01, these are my digital IOs, all right? Goulash level, bean level, this is my analog feedback. I'm not going to use it in the program, but just to show you. So you just define the variables here. And then if you see my PLC here, I have connected in the connections, I have connected digital inputs. This is my HMI start button, stop button, reset button. So basically, this is my just a small HMI start button, stop button, reset button. These are connected. And then you have sensors B1, B2, and B5. So sensors and inputs are already wired in my PLCs. And if you load the system, you will also find already wired. All right. So my wiring is done. Now we have to just write a small piece of code. I've already written the code, but I'm just going to write it again for you. So let's open CODESYS. So in my CODESYS, I have defined a global variable list where I have these variables, and these variables are talking to SIMUMATIK, right? That's the only thing. Now we come to PLC Program. In PLC Program, I have defined some variables, local variables. I'm going to work with the local variables, and then I will interact with my global variables. So these local variables, I have start, stop, reset, sensor B1, B2, B5, and then I have, these are just Boolean, which is coming from SIMUMATIK. And then I have local variables for main steps. So I'm going to write step programming. So I will do step-by-step operation. So I have main step, and then I have filling step, okay? Then there are two timers that I need because nozzle takes some time to come up and down. So I use timer for that. And then I have outputs like motors, fill goulash, fill bean soup, nozzle down, nozzle up. So just a couple of IOs. Okay. So now if you just want to see how this thing works, I can just show you a small example. Let's say I have an output, X motor, or I'm writing in structured text, is equivalent to X start. Very simple logic. So what is going to happen if I press start? It will start my motor. And now what is the start? The start is just a variable here, but the start is also getting a signal. If I go to my read input, there you can see that PLC program X start is getting from GVL input 01, 0. Now what does it mean? GVL is a global variable. This is my data type variable input 01, which was declared here, byte. And 0 means the first input, which is connected to the PLC. And that input is this one, HMI start button. So this is the green button. This is my start button, all right? So that's how all the tagging are being done. So I go to PLC program. I say, okay, first I want to read input because read input is my function, okay? So I will just call this program so I can read my input. And once I write my logic, I will say write outputs. When I'm doing the write outputs, what is happening? This motor is my output. This signal will go to write outputs, and this motor is going to GVL output 01.0. This is the first output in my SIMUMATIK, all right? So that's how, I just want to show you how this SIMUMATIK and CODESYS are linked. So now, just a simple program, and what is the problem? Expected, oh, semicolon is missing. All right, let's now download this code. Later on, I will show you how I write the step. This is just a simple example to show you how interfacing works for those who have never used CODESYS before. So now I'm in the stop mode, I go to run mode, and right now it's waiting for the signal. Now I go to my SIMUMATIK, and here I have to make sure gateway is connected. I start emulation. Now in this case, I have my cans coming automatically. This is I already trigger inside, so they keep on coming. So if I don't move it, they will hit each other. So some kind of physics as well. So I have maximum 3 cans here. Now if I press the button, I see my motor is running. If I release it, it will stop. Okay, very simple emulation. Now I need to write some steps. This is just to show you how SIMUMATIK and CODESYS work. Let me see if you have any questions. Feel free to write questions. I'm checking the comment sections, all right? Okay, let's begin with the programming steps. I will open this window here and CODESYS here. Maybe I will shrink it a little bit and open this one here. Okay, this would be good. So what would be the first step? If you know, you can type in the comments. I'll be happy to see that. Let's go offline. So first step is we read the inputs. We have to read the inputs, all right? Now I will do conveyor control. First, we need to control the conveyor. And I want to use these buttons to control the conveyor, start, stop, okay? So I will write if start and stop. Why do I do that? Because I also have a stop condition, okay? And stop condition is already NC. This is an NC switch, so this will be true by default. So if I press start and if stop is not pressed, then what I want to do, I want to increment or define my I main step as 1. This is actually declared here. So I use my main step, which is a byte data type. I move 1 in that. And this in the end, which means my system isn't running or main steps are running. I will just put system, okay? And I will put else if, another condition, if I press the stop button. So if not X stop, if the stop button is pressed, in that case, I will put main step, I can copy that, to 0. Okay, so this is just one step. If I press start button, main step will be 1. If I press stop, main step will be 0. All right. And this will end my program. You know, there are multiple ways to write the program. You can choose any approach that you like. Every programmer has their own way to program it. But in the end, if it's working for you, great for you. All right, now we say if my main step is 1. Okay, so I will write another condition. If I main step is equivalent to 1, then I have to make sure I have correct case. Now, when I press the start button, what should happen? Now we'll take multiple steps because now I have to do filling steps. In this case, I will write case I filling step off. So if you see here, I also took another byte, I filling step. So filling steps will define what should happen now. First step, motor will be running. Second step, motor will stop. Third step, nozzle will come down. Fourth step, start filling. Fifth step, nozzle go up, and so on. Okay, this is my filling steps. So here I will say if my filling step is 0, that means, sorry about that, waiting, oops, 0 means waiting for CAN, which means I have to start the motor. So in this case, I will say start the motor. All right. Now, as soon as my main step is 1, which means as soon as I press the button, your filling step will start from 0. So motor will be on in this case. Okay. And now when the motor is on, we have these two sensors. The CANs are coming. First, this sensor will be true, and then this will be true, and this will get false. So when this is true and this is false, it means the CAN is there. Okay, this is what was given in the exercise. So I can write if statement. If sensor B2, this is my B2 sensor, if this is true, and not sensor B1, this is my B1, not means if this is false, then what should happen? So when the CAN is positioned here, what you need to do, you need to stop the motor because motor has to stop to filling. Then I will do X motor false. Okay. And then I will increment the step from 0 to 1. End if. Okay. So my 0 step was just waiting for the CAN. When the CAN is there, we move to next step. Next step is what? Nozzle down. All right, nozzle down. So in this case, you can see I have variables here, nozzle down and nozzle up. So I take nozzle up. First, I make sure nozzle up is not true, so I make it false. And nozzle down, I make it true. All right, so I bring my nozzle down as soon as the CAN is there. And now the nozzle takes some time to come down. So let's say I wait 1 second, okay? In this case, I have to define a timer. So I will just define the timer here. Nozzle, I just put the text nozzle timer. And I will say, okay, these timers are already defined here, TON and TON1 and 2. These are already declared as on delay timer. So I can just write TON. And now, when should this timer be on? When your step is number 1. So when you are in step 1, then this timer should start. Okay, so I can type here input when I filling step is equivalent to 1. This is your input. And then I can define my preset time as 1 second. Okay, I just take 1 second timer. Okay, so this is the timer for 1 second when I am step number 1. So this will be here. Okay, and then I can write if this timer is done. So when the timer has a done bit, which will be TON_1 dot Q, then what should happen? Then we move to the next step. So when the nozzle is down, you go to the next step. So I can just copy this one. I go to filling step 2. All right. And then we end this if statement. Then we go next step. Here we have start filling. Now we have to start the filling. Super easy. So here you can do, I have some outputs here. Fill goulash or fill bean soup. So you can fill any of these liquid. These tanks had goulash and bean soup. So whichever output you turn it true, the same material will come out. So I will say I will fill the goulash and I can make this true. And now when it starts filling, we have to wait for the signal from the sensor. When the sensor says stop, now it's full, then we have to stop the fill goulash. The sensor signal is B5. Okay, so I can write very simple, if X sensor B5, if this gets true, in this case, let me see if you have questions. Very informative video. Thank you, Juicer, for your comment. I hope you're gonna like it. So when sensor is true, then we make this false. Okay. We make this false, and then we go to the next step, right? Step number 2 was it. I will copy that. Go to step number 3. Now the can is full. What needs to be done? We have to move this nozzle up again. So step number 3 is filling done or move nozzle up. So in this case, I have to first stop the filling. So let me see. And filling has been stopped here. Now I can just move the nozzle up. So X nozzle, I can maybe just copy that. It's much easier. So before up was false, I make up true and I make down false. Okay, now nozzle is going up. And now again, we wait 1 more second for that, for this nozzle, okay? And this 1 second I can take again. I can maybe take another timer just for simplicity. This time I take when I am in step number 3. And this is my timer 2, okay? Step number 3, I wait for the timer to be finished. So if TON_2.Q, then what should happen? We go to the next step. 4. All right. And now what is the next step? Once the can is filled, once the nozzle is up, you move further. So you move the motor or you run the motor. So I can just put X motor is true. And now when the motor is true, this sensor which was true because of the can will become false. So we take this condition. If X sensor B2, this is sensor B2, then I go back to my filling step 0. When I go back to 0, it will start the whole sequence again. Okay, so this is my end case here. And remember, we had used this if statement. If main step is 1, then this whole sequence will come. But what happens if I bring main step to 0? In this case, I will use here else, and I will put all the outputs to false. Okay, when you press the stop button, I want motor to stop. I want my fill goulash to stop. And I also want my nozzle down also stop. And nozzle up as well. So whatever situation of the outputs are, it will get false. Okay, let me see if everything is okay. All right, now comes the final step. We also have a button, reset button here. This is just to reset the sequence. If you are stuck somewhere, something is happening, you stop the operation. Now we want to start again. So you need to reset the steps. So here I can mention if not reset. By the way, this reset is already defined here, okay? So this is, it's already declared. Then I would say my I filling step will be 0. All right, that's it. This we don't need. And then we have right outputs here. So I hope this program has no errors. We can verify that. Let's compile. So some questions here. Hey, Rajvir, good to see you on LinkedIn again. Great info as always. Thank you, Daniel. Great to see you as well. What is the difference between Siemens SCR language and CODESYS? How many PLC controllers support CODESYS? This is a question from Ankur. Oh, a lot of questions. Okay, I will answer your questions in the end. You have asked a lot of questions, good questions, but I will answer in the end. Arias, thank you. You're welcome. All right, let's see if this works first. And I think I compiled, no errors. Let's go and start login, download. There you go. Now we're in the stop mode. Let's go to start mode. PLC is running. And now here we are. Let's start the emulation and I press the start button. Let's see. Motor is running. Cans are coming. Let's see if it works. There you go. Nozzle goes down. Step number 2, start filling. Then comes step number 3, nozzle up. And then run the motor. Oh, there is some problem here. Nozzle is going up and down. We have done something wrong. Timer 2 is done. We go to step 4. Sensor B is true. We have to find the problem. This is not correct. Okay, let's see. Let me just make it a bit smaller. And go offline. So if main step 1, filling step 0, motor is true, sensor 1. Then motor is false, step number 1, nozzle down, start filling, fill goulash. Then go to step number 3, nozzle up true, nozzle down false. Then we wait for the timer. Then we go to step number 4. And timer is step number 3. That's correct. Let me see if I did some mistake. Nozzle down, false, nozzle up true, T to Q, step number 4. Oh, this is not here. It's not true. When the sensor is false, that's the problem. Let's try. Because the can leaves the sensor will get false. It should not be true, so I forgot to put the not. But you can see that how easy it is to realize the problems using digital twin before working on a real scenario. All right, so now it should be up and running. Let me go online, start the emulation, start the motor. All right, there we go. Now we check how it's working. Nozzle goes down, start filling. You can see it's filling. And the sensor gives you a signal when it's full, goes up, goes further. There you go. So now it's working good as per the instructions given in the book. I hope, Tom, if you're watching it, I hope I succeeded in your exercise. Although you were asking to fill the can with the water, but if you see the fundamentals here are same. It's just because instead of a jerry can, we have a small can. And what you can also do, you can also extend this logic because we have another output. We also have fill bean soup. So you can make a logic that first can should be goulash, second should be bean soup, and then goulash and bean soup. Or you can have some control from your HMI. You can make visualization in CODESYS, and you can control what you want to fill. And not only that, you can also count the number of bean soup cans and goulash cans or total cans, or you can also count how much time it took to fill the can. You can do some analytics as well. So there are multiple options to extend this project and make some nice dashboard. And you can also mention the orders. Hey, I want 5 goulash cans and 5 bean curry cans. How much is the estimated time to create this? And if you know how much time it took to create one, you can do some analytics and some mathematics and find out the information, all right? So the options are endless. But if you stay with me in the live stream in the next months or next weeks, I'm going to show you once we will continue this live stream and we're going to put a lid on top. And after putting a lid on top, we will put a label on top. And then once the label is done, we will stack these cans. And then we will use a robot to do pick and place somewhere and we can do the storage. So, but we will do step by step, right? Now, coming to your questions, right? I see a lot of comments coming here. So I will take the question from Ankur. So Ankur is asking, what is the difference between Siemens SCL language and CODESYS? Very good question. So Siemens has some difference compared to structured text. So this CODESYS is working on structured text programming language. Siemens also follow that, but they have some of their own rules. So it's not 100% same. It might be a little bit different, but it follows the same fundamentals of structured text programming. But Siemens SCL has some extra rules how they do that. All right. But if you know structured text, you can program SCL very easily. Or if you know SCL, you can program this easily as well. So it's quite relatable. Your second question was, how many PLC controllers supports CODESYS? Good question. In my knowledge, I don't have a number in my mind, but if I recall that, I think Vago PLC, you can program using CODESYS. Revolution Pi is a controller. It's an edge device. It can be work as a PLC or an edge device. You can program using CODESYS. There are some controllers from Turk. I have one IoT device from Turk. I have an HMI from Turk, which has a PLC inside you can control by CODESYS. And I think there are multiple. If you know more, please type in the comment and so that others can know as well. And interesting part is because you asked this question, this year, 2025, I'm going to make a new course on CODESYS. So that's my target for this year. And in this course, I will talk about how to use CODESYS without PLC, like a soft PLC, and then how you can use it with hardware. So if you want to write some information to a different remote PLC or remote edge device, how you can do that with CODESYS. Or if you want to read via IO-Link device, how can you do that? So I will use a hardware and software integrated course on CODESYS. That will come in 2025. Another question was, what can be done extra with CODESYS, which is not possible in SCL? So CODESYS has a lot of, I don't know the correct word for that, a lot of modules, a lot of plugins. So they have a lot of libraries, which SCL do not have. So SCL, in TIA Portal, you also have your own libraries, but CODESYS has free libraries that you can use right away, and it's open to use. They have documentation. Libraries, by libraries, I mean if you want to use CODESYS for, I don't know, Ethernet IP or for IO-Link, or for Modbus. So there are libraries that you can use right away in CODESYS. Can we use CODESYS in SCADA designing? If yes, SCADA at present supports CODESYS. I mean, SCADA designing is a completely different platform. You can't use CODESYS there. CODESYS is for programming the controllers. For SCADA, there are different platforms and different ways to make SCADA screens. You can use Ignition SCADA, and this is like a drag and drop interface. You can drag your windows, drag your buttons, define your tags, and then you can link that to CODESYS. So CODESYS is like a base layer, and SCADA will be the top layer to control what is happening in the CODESYS. This you can do. So I hope I answered your question, Ankur. And Aryan, you were asking, thank you, teacher. You're welcome. And Ankur, can we use CODESYS in SCADA? I think I answered that. Daniel is asking, Rajvir Singh, Daniel, who worked for Siemens Video Transmission. Okay, Daniel, I get to know you now. So we worked together before. Great. So let me know if you have any more questions. So I think I'm pretty fast. I'm pretty done, but I will show you some more thing about how can you get this course for free. I have a free course on this CODESYS and SIMUMATIK, and this video lecture will also be available on this website. So let me show you where you can find that. So if you go to, I can open a tab here. If you go to my website, codeandcompile.com, there are many courses there. There are some free courses, some paid courses. And if you go down, or maybe just go click on courses, and then you will see some free courses. So I have a free course on safety controller, mechatronics and IoT, PLC next generation PLC, Control-X Core, interfacing 3D camera. And this is, oh, sorry, a pop-up for some news. And this is the course, PLC exercise using SIMUMATIK and CODESYS. And if you click on this course, you will find my earlier lessons. So here, I don't have much lessons right now. Let me show you that here. So I have introduction to this course, and I have this video logic circuit exercise. So I solved many exercises from this book, and that will be in this course. So here you have one lecture for 1 hour. There I solved 9 exercise or 8 exercise. And then you have another lecture of another 1 hour. There I also solved exercise. And this lecture will come here, the third one. And if you want to have the copy of my CODESYS program, you can also find in this course. Okay, so go ahead and register for this course, completely free. You don't have to pay for that. No credit card. Just sign up and start using. And like I told you, you can use SIMUMATIK as a free user as well in the beginning. And if you are interested, you can buy the license. When you buy the license, then you can create your own systems. For example, this system has been created by us, by our developers, by using the license, right? But if you don't want to use the license, just sign up for free, play around, and if you find it interesting, you can buy the license anyway later on. Coming to the license, there are different types of licenses for SIMUMATIK. You can go for monthly subscription, which is 25 euros a month. You can go for 6 months access or 6 months license access, or you can go for 12 months license access, and the price is here, 99 euros and 249 euros. This is one-time price, right? And with that, you get some features, like you have all standard features, which are here. You get 10 credits and you have premium supports. And if you want to buy this license, you can just go here and click, and then you will go to a page where you can buy the license. And if you use a coupon CAC20 off, this will give you 20% off on the licensing pricing. I hope this coupon is working. If it's not, just let me know. And not only that, if you want to buy my other courses, because I have several bundles on Siemens, IoT, Delta, Micro 850, Siemens, Node-RED, JavaScript, or Code and Compile Pro, which has access to all the courses. You can use a coupon code Code and Compile Live. And this will give you 25% discount flat on the price. And then you can get access to all the courses that you want to buy. All right. So this was about Code and Compile. This is about SIMUMATIK. And let me know if you have any other questions. Otherwise, go ahead, join this course, and let me know if I can do something for you. This is again some licensing information. And the next live stream will be about putting the lid on this can, putting a label around it, and doing some counting and stuff. So stay tuned. You can follow me on LinkedIn, and there I'll be giving you all these updates about the next live sessions. And if you are interested, tomorrow I'm doing a live webinar with SIMUMATIK, where we are showing, no, not tomorrow, sorry, next week we are doing this webinar. And there we are showing how you can build a SCADA robot from scratch. You can also build robots. I'm going to show you how, and then you can simulate this robot using a free software as well. So a lot of learnings to do using SIMUMATIK. That's a software I'm using quite a lot nowadays to create some lessons. All right. So thank you for watching. And if you have any comments, feel free to get back to me. I'll be happy to answer you. All right. Have fun. Enjoy your day and take care. Bye-bye.